Hi everyone, this is Richard. In this video, let's talk about class properties. So your objects have properties just like everything else does in life. For example, if we use our same class dogs, the class dog, the dog has properties. It has legs, it has tails, probably wags the tail, but that's a method, the wagging, because it's a doing something. But it's color, fur, and stuff like that. So it has properties, and we can give it as many properties as we want to do. And so we'll talk about that. Before we do, let's talk a little bit about interface. So when you look at your computer, you have a bunch of cords sticking into the computer, right? Some cords have power going into it, some have power coming out, and some have data going in and out and stuff like that. When you think about it, like for example, a USB, you're just getting a plug and you're shoving it inside. But if you open the computer up, there's a lot more complicated stuff going behind there. But the makers of the USB standard and the makers of your computer don't want you to interact with that, right? They want you only to stick a plug in because the more you open it up and expose it to the world, the more you're going to screw it up, right? You're only going to make it worse. So the same is true for software. As a programmer, you don't want people to screw up your program because you know they will if they can. So you want to restrict access to certain parts of your program so that people don't mess it up. Same thing with the USB. Make it simplified, make it relatively dummy-proof as much as possible so you can't ruin it, but don't expose the internal workings to the outside world. Or bad things can happen, and usually do, okay? And that's the importance of interface. That's why we call it application programming interface. Show the world only certain parts of your code that they actually need to. Show them what they need to interact with it, but not anymore, all right? And this doesn't mean hide your code. It means make the code inaccessible. You cannot access it in certain areas of the program itself. And so we'll talk about that. And we'll give examples of that, okay? That talks about something called an encapsulation. The encapsulation refers to what you can and cannot access in a computer program, at least with respect to object-oriented programming. So when we created a class, you don't want the entire class accessible, only parts of it. Now, I don't know what protected internal means, okay? So these are the types of encapsulation. I'm just going to go over public and private, and that's all we really need to know for this stage, at least I hope, all right? So what private means is in the class, this information is accessible in the class only and not outside the class, all right? So if you instantiate this, again, this is an instantiation of the class, but it's not in the class. So once you get out of the class, private is not seen any longer. If it's public, it is. Okay, so let's give an example, okay? So I'm going to say public int legs. What I can do, actually, I'm just going to make it private right now. If I put dog.legs, there is no choice for legs right here, okay, right? But if I put public, then it should be accessible right here. Okay, so I hope that makes sense. Your computer won't let you access it if it's private because you left the class. But if it's public, then you will be able to see it. And you know, some things are private and some things are public. What are those things? Okay, well, let's go into a little more detail. When we talk about properties, those are the things that, for the most part, you interact with in a class. Not always. It depends, because you could keep it private and do all sorts of stuff and just expose at the very last moment some feature. Like if there's lots of calculations going on, you could expose not all the calculations to the public, just that which you want them to see. So a field is basically a variable that holds data. So this would be a field, right? Private int legs, private bool tail. Those are called fields because they hold the property itself, the data itself. And this is a super simplified version. So what if you got the data from a different source and you calculate it somehow? That's the data itself. And so you don't want people manipulating the data itself. You want to be able to display the data in some other, because again, this could be coming from some other source. You don't want to manipulate that source, or you don't want to cut that source off. You want to display it in a different way, which is through the properties. All right. So notice the fields are generally lowercase, properties are uppercase. And so we'll say public, these are private, so you cannot access them outside of the class. This is public, it's going to be int legs, okay? And properties, which are, again, the characteristics of your object, well, first of all, because you don't do something, it's not like a method where you do it right now. You don't call it. So you don't need call functions, the parentheses, when you display the properties. Okay, so keep that in mind. With properties, you have what we call getters and setters. Okay, so the property, you have to give it a value and you have to get a value. Okay, so if a dog has a color, you have to give it a color. It's got to have some color, right? So it has to set the color. But what if somebody says, look at the dog, what is the color of the dog? You have to get the color itself, right? So we'll keep that in mind. So the get actually is the more important, well, not more important, but we'll keep this in mind. So if I access legs, the property of legs, it will return the data, which is the field of legs, right here, right? So that's one way. But what if, something happened, the dog grew a fourth leg, or a fifth leg? How many legs do a dog have? So 7 or 8 or something like that. So it grows more legs, okay? So you want the legs equal value. Value just means that it's going to be set in the future when you instantiate the object. Okay, so as a default, what's going to happen? As a default, when you call it, legs is going to be 4 because once you receive the legs, you're going to return the value of 4. But you can always set the value of legs to something more complicated, right? But the setting is only going to happen within this class, and so therefore you can manipulate legs, the data of legs. So this is not a great example of manipulating the data, but that, again, because this is such a simple program, it's hard to see the differences between the two. So it's more of understanding the concept itself. So we instantiate dog, and then we'll say dog. Actually, let's just run it. So what we just said is it should be return legs. It should equal 4. So this should give me the number 4, right? I'm going to set this to run back in the debug console, okay? Next video. So number 4, okay? But what if I want to do something else? What if something happened and, I don't know, bit his leg off or something like that? Dog.legs equals 3. You can always change it because you got a setter. So you're allowed to change the value right inside of here. So it should run 3, right? Right here. And of course, you could do all sorts of things. You could potentially say, something, I don't want anybody else to set the value. This is what the value is. That's it. And so you could do something like that. And so, again, you would run it. But if you try to do it, legs equals 3, you couldn't actually do that because there's no setter. Okay, read only. I guess you could have a no getter, only a setter, because if you're going to only, I don't know why you would do that. I guess it's possible, okay? So we'll keep that in mind. One more thing. You might actually see code that looks like this. Get set. It's just like this. Oh, I got to capitalize this. Because this other lowercase, it would be the same one as this one. So I could do get set, and I don't actually have to use this one, right? This one. This is basically just a shorthand. This is a shorthand for this. So this is just shorthand for this, and you don't actually have to write this on out. So it's just a simplified version. It's just understood that this is acting as if it's a field, right? It's a property, but you're acting as if it's a field, so you need the get set right here. And I don't think you can directly give it a value here. I think you have to give it a value later on, like right up here. So I'm going to say oh, actually, dog.tail. False. And then .tail. So here it's true, but I commented that out, so it should be false. False right here. If you can make it true. And I think by default, it's going to be false. I'm not positive on that. If you don't give it a value, or it might just not run. It'll be like null, but null, null, but I don't know if there's a default value. The default value is false. So unless you give it a true value, it's going to be false. Okay, so I hope that explains properties, fields, the concept of encapsulation, which is key to object-oriented programming, through the interface, and then the public and the private. So most of the time, I'm just going to write public in most of these just because it doesn't really make a difference. But in practice, it would be a good idea to practice keeping your data fields private. Okay? Thanks.